According to the National Electrical Code, specifically Section 90.5 Bone, services must be disconnected at the service disconnect before any conductors or equipment are removed or replaced. This requirement applies universally to all services, encompassing buried power services. When a building is demolished and a buried power service remains connected to the utility transformer, the National Electrical Code mandates that the service be disconnected at the service disconnect. This is a critical safety measure to prevent accidental electrocution or other electrical hazards. Ignoring this requirement can lead to serious consequences, including potential injury or death, as well as significant legal liabilities. The NEC intent is to ensure that all electrical work is performed safely and that potential hazards are eliminated before work begins. In the context of a demolished building with a still energized buried power service, the first step is to identify the service disconnect. This is typically located near where the service conductors enter the building or structure that was demolished. However, since the building is no longer there, the original service disconnect location may no longer be accessible or even exist. In such cases, the disconnection must occur at a point upstream of the original service disconnect, ideally at the transformer itself, if that is where the service originates. The disconnection process involves several key steps. Firstly, it's essential to notify the local power company of the situation. They will likely need to be involved in disconnecting the service at the transformer, as they own and maintain that equipment. Attempting to disconnect the service at the transformer without their involvement could be extremely dangerous and could violate local regulations. Secondly, before any disconnection work begins, it is crucial to verify that the power is indeed off. This can be done using appropriate testing equipment, such as a voltmeter or multimeter, to ensure that there is no voltage present on the conductors. Remember to always follow lockout-tagout procedures to prevent accidental re-energization of the circuit while work is in progress. Thirdly, once the power is confirmed to be off, the service conductors can be safely disconnected. This may involve cutting the conductors and capping them off, or removing them entirely, depending on the specific circumstances and the power company's requirements. Be sure to use appropriate tools and personal protective equipment such as insulated gloves and safety glasses when working with electrical conductors. Fourthly, after the service is disconnected, it is important to properly abandon the buried conductors. This may involve removing them entirely from the ground, or, if that is not feasible, capping them off and burying them in accordance with local regulations. The goal is to prevent future contact with the conductors and eliminate any potential hazards. Finally, document all work performed, including the date, time, location, and the names of the individuals involved. This documentation can be helpful in the event of any future questions or issues. In addition to the specific requirement in NEC Section 90.5 Bone, there are other relevant sections of the NEC that may apply to this situation. For example, NEC Article 230 covers service conductors and equipment, and it contains numerous requirements related to the installation, maintenance, and disconnection of service conductors. NEC Article 300 contains general requirements for wiring methods, and it may include requirements related to the burial depth and protection of underground conductors. NEC Article 310 covers conductors for general wiring, and it contains requirements related to conductor ampacity and insulation. NEC Article 408 covers switchboards and panel boards, and it may include requirements related to the service disconnect. NEC Article 110 covers requirements for electrical installations and may include requirements for safe work practices. It is important to consult the latest edition of the NEC and any applicable local codes to ensure full compliance. Failure to comply with these codes can result in fines, penalties, and even criminal charges. In summary, the NEC requires that buried power services be disconnected at the service disconnect before any conductors or equipment are removed or replaced. This is a critical safety measure that must be followed to prevent electrical hazards. The process involves notifying the power company, verifying that the power is off, disconnecting the service conductors, properly abandoning the buried conductors, and documenting all work performed. Always consult the latest edition of the NEC and any applicable local codes to ensure full compliance. Consider the implications of improper grounding, which can create hazardous touch potential if a fault occurs. Grounding ensures a low impedance path for fault current to return to the source, tripping the overcurrent protective device and energizing the circuit. Without proper grounding, a fault can energize conductive materials, creating a shock hazard. Always verify grounding integrity during disconnection. Consider also the potential for induced voltages in buried conductors even after disconnection. Nearby energized conductors can induce a voltage in the abandoned conductors, creating a shock hazard. Use appropriate testing equipment to check for induced voltages before handling the conductors. Consider the effect of environmental factors on buried conductors. Moisture, corrosion, and physical damage can degrade the insulation and create a ground fault. Inspect the conductors for signs of damage before disconnecting them. Consider the possibility of underground utilities in the vicinity of the buried conductors. Before digging to remove the conductors, contact local utility companies to locate any underground utilities and prevent accidental damage. If the service voltage is above 600 volts, additional safety precautions are required. High voltage services require specialized training and equipment. Consult with qualified personnel before working on high voltage systems. In addition to the NEC, consider applicable OSHA regulations for electrical safety. OSHA regulations provide requirements for safe work practices, personal protective equipment, and training. Comply with all applicable OSHA regulations when working on electrical systems. Ensure that all personnel involved in the disconnection process are properly trained and qualified. Electrical work should only be performed by qualified individuals who have the necessary knowledge, skills, and experience. Develop a detailed work plan before starting the disconnection process. The work plan should identify potential hazards, outline the steps to be taken, and specify the necessary safety precautions. Conduct a job briefing before starting work to discuss the work plan, potential hazards, and safety precautions. All personnel involved in the work should attend the job briefing and understand their roles and responsibilities. Use appropriate personal protective equipment, including insulated gloves, safety glasses, and arc-rated clothing. PPE provides protection from electrical shock, arc flash, and other hazards. Inspect all tools and equipment before use to ensure that they are in good working condition. Defective tools and equipment can create a safety hazard. Use lockout-tagout procedures to prevent accidental re-energization of the circuit. Lockout-tagout procedures require the installation of a lock and tag on the disconnecting means to prevent it from being turned on. Verify that the circuit is energized before starting work. Use a voltage tester to confirm that there is no voltage present on the conductors. Maintain a safe working distance from energized parts. The safe working distance depends on the voltage of the circuit. Use barriers and barricades to prevent unauthorized access to the work area. Barriers and barricades help to protect workers and the public from electrical hazards. Provide adequate lighting in the work area. Adequate lighting helps to improve visibility and reduce the risk of accidents. Keep the work area clean and free of obstructions. A cluttered work area can create a trip hazard and increase the risk of accidents. Use ground fault circuit interrupters to protect against electrical shock. GFCIs detect ground faults and quickly de-energize the circuit. Be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Use arc-rated clothing and other PPE to protect against arc flash. Develop an emergency plan in case of an electrical accident. The emergency plan should include procedures for contacting emergency services, providing first aid, and evacuating the area. Review the emergency plan with all personnel involved in the work. Document all electrical work performed. Documentation should include the date, time, location, and the names of the individuals involved. In conclusion, disconnecting a buried power service is a complex and potentially dangerous task that requires careful planning, execution, and adherence to all applicable codes and regulations. By following these guidelines, you can help to ensure the safety of yourself and others. And remember, if you are not qualified to perform electrical work, always consult with a licensed electrician. Electrical safety is paramount.